right, we're ready to begin. Hello, everybody, and welcome to the monthly CQA Solutions PDH webinar. So glad you're able to join us today. Many of you might be looking at your screens right now and thinking to yourselves, hey, that's not Glenn Tepfer. Well, you'd be right. I'm not Glenn Tepfer. I'm Brent Duganero. I manage the health and safety as well as the field work for CQA Solutions, and I'm filling in for Glenn Tepfer today. So again, thanks for joining us. Today we'll be talking about geosynthetic safety, and our goal is to ensure that every person that's involved in a geosynthetics installation, from the laborer to the CQA technician, from the engineer to the site owner, and even the regulatory agency, if you're out there working or even walking on the geosynthetics, we want to make sure that you get home safe. So today's webinar will run for an hour, and we'll have Q&A at the end. So if you have any questions along the way, please make sure to type them in, and we will take a look and address those questions at the end of the webinar. Just as a reminder, all the previous webinars can be found at the CQA Solutions website. You can also scan that QR code you see on your screen. Just also as a secondary reminder, PDH hours will only be awarded for those who attend the complete live webinar like you guys are right now. So a quick outline for today. We're going to be working through a hypothetical small project for a geosynthetic installation. And as we talk about some of the tasks, we will be discussing the common hazards and the mitigation efforts that you can employ to make sure that you come home safe. So we'll start out talking about just some general safety issues and some concerns, and then we'll really get into our project. We'll discuss material offloading and inventory, subgrade acceptance, geomembrane deployment, trial seams, geomembrane seaming and repairs, and then non-destructive seam testing. We'll also talk about covering the geomembrane, and then we'll even spend some time talking about some other common materials, such as your geonets, geocomposites, and your GCLs. So let's get started. So what we often do when we start a safety class, we start with a little exercise that I do, where I pass out pieces of paper and boxes of Crayola crayons and ask everybody to draw their front door. So what you're looking at right now on your screen is a picture of my front door. We do this not just for the fun of it, but it really is an exercise to demonstrate that there is somebody waiting on the other side of that door for you to come home to each night. And they're counting on you to be home. So we talk about some of the best practices moving forward that you can employ that hopefully will keep you and your coworkers safe and manage to get home to your own front doors. So just as we get into this training, I want to make sure everybody understands this is not an OSHA course. It's not an MSHA course. And, we're going to be talking about just a basic geosynthetic installation. So we're going to, we don't have time to get into all the details. So we're going to leave out working from heights and confined spaces, equipment operation, and low oxygen or explosive environments. I also want to point out that you're going to be seeing several photos. This presentation is pretty slide heavy. You see a lot of photos from job sites with some pretty unsafe practices. Just keep in mind that if you're on a job site and you see something unsafe, make sure you stop work. If in doubt, stop. You'll be wondering why CQA Solutions didn't stop work. It's just, on many of our job sites, we have the ability to stop work for ourselves, but not always other contractors. So just kind of keep that in mind. Again, the most important thing is if you're in an unsafe situation, stop, back up, and get yourself into a safe situation, and if you're able to, make sure the work stops for everybody. So we'll start with PPE, the personal protective equipment. I started this work back in 2006. And back in those days, I came from the retail world, and all of a sudden I find myself out on a construction site, and it looked to me like a bunch of wild cowboys were out there. You can see on the photo on the left on your screen, those guys, there's no PPE being used, there's no safety vests or hard hats. Whereas compared to now, in contrast, you can see, the same task, they're deploying liner. You can see that they're wearing hard hats and vests, and as our industry evolves, we employ more and more safety best practices to make sure everybody stays safe. So speaking of PPE, at a very least, you would be expected to wear level D PPE. So that would include hard hat, safety vest, steel-toed boots, safety glasses, gloves, and earplugs. Now, as you move into other types of situations that we may not be talking about today, the level of your PPE would need to be increased or modified. It's also important to remember that some PPE, just by wearing them, may create other hazards. So like something as simple as your steel-toed boots, as you walk from a muddy area onto the geomembrane, you could be tracking mud on there. Besides being a quality concern, it's a safety issue. Geosynthetics can be pretty slick, and if you have wet or muddy boots, that's going to cause you to slip and slide. So before you step onto the geomembrane, make sure we're kicking off our boots. All right, so before we get too far along here, let's talk about some general best practices regarding safety. We're just pulling onto our job site, and before we get involved and start doing anything, let's do a 2-minute rule. What I like to do there is look around, see what's happening, get a good survey of what's, all the tasks that are occurring, any potential safety hazards that might be identified. And before I get out of the vehicle, I do a self-check. Just make sure I got all my equipment on. Do the pat down? Do I have my hard hat? Do I got my vest? And then once I'm sure I'm good, if I'm with somebody and we're getting out of that truck, I do a peer check. So you should check your peer, and your peer should check you. One of the most common things we see people forget when they're getting out of the truck is the hard hat. And then the other thing is avoid tunnel vision and make sure you're staying alert. It's so easy in the world of geosynthetics that you're always looking down. And geosynthetics is usually installed on on the ground. So we're often looking down and we're forgetting to look up. So what I tell everybody is to look up, look down, and look all around. Then make sure you're fit for duty. When I say that, a lot of people think, from the physical aspect, but really it's also the mental. Where's your mind at? Are you ready for work mentally? Because if you're not, your mind's going to be elsewhere. Maybe you're thinking about the weekend, or maybe there's a holiday coming up, or you got plans this evening, or you want to make sure that your mind is focused on work so you can stay alert. Also, job sites throughout the world have different types of environmental concerns, whether it's heat, cold, wind, precipitation. You're going to know better what your environmental factors are, but that's something you should always be aware of. And we're going to talk about some of these later on, especially the wind when we get into the deployment. All right, so we're on our job site right now, and our project's getting ready to start, and the delivery trucks are coming in, and they have our rolls of geosynthetics. So we need to unload those, and we need to stockpile. So a concern with that would be obviously the heavy equipment, and everybody knows, to be safe around heavy equipment. But with this, we got the wider rolls of the geomembrane and whatever geosynthetics we're dealing with. So that really increases the turn radius of that equipment. So you have to be really careful around that, especially if we're working in tighter areas. Sometimes the areas where we're unloading are, there's not a lot of space. Sometimes they're indoors, like you can see in this photo here. So that really, really limits the area that, they can operate. And just to be safe, let them do their job before you approach the rolls to do your tasks. That's maybe you have to do an inventory. So the unloading also presents another potential issue, is working from heights. The flatbed of the truck, somebody has to be up there to hook up the straps and do the rigging to get the rolls down. When we're dealing with OSHA, we have 2 different regulations that we could fall under, and each one has a different requirement for fall protection. So the general industry would be manufacturing, warehousing, et cetera. That would be 4 feet height, okay? Whereas the construction, which I'm sure just everybody here would fall under, would be 6 feet. So the flatbed truck, typically they're about 5 feet. So we're somewhere in the middle. So you're not obliged to follow the general requirements, but maybe as a best practice, maybe we develop some sort of an engineering change, maybe some sort of mobile work platform to keep folks safe. So we've unloaded our material from our trucks, and now we have to stockpile them somewhere. So we want to be careful that we're chocking the materials, they're properly stacked, and they're the right height, and we're not climbing on those stockpiles. You can see in this photo here that whoever stockpiled them put them kind of crisscross, perpendicular to each other. That's not really the safest, and I would be concerned about them slipping, rolling down, and somebody working below that might be pinned or trapped. This photo here shows GCL stacked, and they're 5 rolls high. So yeah, that might be a situation where we might have a safety concern. If we look at, this is an example of Agru's GCL drop-in specs, and it says stack no more than 3 rolls high. Now that may be due to a concern for quality. GCL, you don't want to crush the material, and we don't want to crush the core. But also, we don't want to stack them so high that they pose a risk of shifting. I mean, it's heavy material. So we want to try to follow the manufacturer's specifications, and you can do this for whatever material that you have coming into your site. Double check, and we want to make sure we don't stack them too high. We obviously don't want to be climbing on the rolls. These rolls have a tendency, they could shift, and somebody could get easily trapped. We also want to be very careful about where we plan to put our stockpiles. We want to be cautious and consider the surroundings, the travel paths to and from our stockpile to our deployment area, and what other activities might be going on in that area, as well as making sure we have access on all sides. So you can see in this photo here, we've got some material that's stockpiled, but it's right in front of that porta-john. So we have people coming and going from the porta-johns, but meanwhile, throughout the day, we have the forklift coming, rigging up the material and going to, take it to the area of deployment. So it's not really the safest situation to be in. Likewise, here's another one where we're unloading, and the stockpile is in an employee parking lot of all places. So you can see the truck in the vehicle in the foreground, and also in the back to the left, you can see, looks like there's an office storage, an office building there. And then if you look beyond that blue dumpster to that hill beyond there, beyond that hill is where we're deploying the geomembrane. So we have a forklift all day long running in between those areas into the employee parking lot next to that office area. So we really want to think through where we're putting our stockpiles, what other activities could be going on. Likewise, think about where the stockpile is in relation to where you're going to be deploying it. So do we have to cross any operational roads? So this is a haul road specifically for the waste to be brought in on that site. And those trucks are going back and forth all day. And they were allowed to operate at a faster speed than what we do in our pickup trucks. So you just want to be careful and consider what other operational traffic might be occurring on your job site. I mentioned access on all sides of your rolls. So this photo here, you can see that they've got it chocked. They use some soil to prevent the rolls from slipping and sliding. But they did not allow enough space for QA/QC to get in between the stockpiles to access the roll numbers. So you want to be able to get in and get out safely. And react. As you can see here, we got some local critters, and sometimes they're not even local critters. If you think about these rolls of material, maybe it's sitting in a field where they are manufactured, maybe down in Texas, and it's being delivered to a job site up north where maybe you're not expecting a scorpion or a rattlesnake, but maybe we have a hitchhiker. So you want to be really careful about that, and as well as anytime you're removing tarps or sandbags from your stockpile, sometimes those tarps are sitting there for weeks and you don't know what's hiding below. So you should always use caution when you're removing the tarps, making sure you got gloves on, and just being maybe expecting something that could be underneath there. Likewise, you want to consider the location in regards to what you have to go through in order to get to your stockpile. So here we have to cover an area that with a lot of overgrown brush, and ticks might be an issue. Okay, so we got our material on site on our project, and we got it stockpiled, and now we are ready to prepare subgrade. On subgrade preparation, you're going to see smooth drum rollers, and everybody knows when you're working around heavy equipment, they always say, hey, make sure you make eye contact. That's good. You should make eye contact. But if I've never operated a smooth drum before, but I know they go back and forth all day long. And to me, my mind wanders too much, and I would be pretty bored doing that job. Would probably become pretty complacent. So I try to keep that in mind when I'm working around all the heavy equipment. Eye contact's not enough. You got to make some sort of communication, and whether that's via radio for the site radios or hand signals, some sort of predetermined communication so that it is understood what your intent is. And then do not proceed until the equipment has come to a stop, and the operator understands what your intent is. Some sites have what's called a man on the ground policy. And when I first heard this, I thought that was this like, what do you do if a guy's laying dead on the ground? But it's not that. What that is if somebody is working on the ground, if the feet on the ground, surveyor or QC walking around doing density tests, if there are personnel on the ground, that becomes an exclusion zone for the heavy equipment. Okay, so that's called the man on the ground policy, and that's actually a pretty good policy to employ if you're not already using it. And if you're a site owner, you might want to consider adding that maybe to your health and safety plan. Okay, so we've got our subgrade prepared, and now we're going to be excavating our anchor trench. All right, so just about in every geosynthetic project, there's an anchor trench. We've been on some, you're doing a building, but in most cases, you add an anchor trench. Now that presents a fairly common trip, slip, and fall hazard. You got to get from point A to point B, and you got to cross that trench somehow. So one option, which we do not recommend, is either jumping or stepping across that trench. So we need some alternatives. One is you could walk to the end of that trench and go around it, thus eliminating that hazard. But in doing so, you could actually find yourself in the line of fire of another hazard. Maybe there's an excavator over there excavating that trench. So you want to be careful that you don't find yourself walking into some other danger. So another option is maybe you step into the trench and you step back out on the other side. That way there's no slips, trips, and falls going on. And be careful, there might be sandbags or something else down in that bottom of that trench that it might be an uneven surface, so you got to be careful doing that. Another option would be using a temporary bridge, and we'll talk about that here in a moment. So here's an image of somebody that just did the run and jump deal. We certainly don't want to do that. So here's our temporary anchor trench bridge. Some installers will utilize this. We got two examples shown here. One to your left looks like it's a piece of plywood and looks like it's got a couple 2x4s nailed to it. I'm not sure how stable that one is. The one on the right is a little more stout, might be a better bridge crossing for you. But when we're using these temporary anchor trenches, there's some things that maybe we should consider. There's actually some OSHA regulations that we should consider. I said this is not an OSHA course, and it's really the furthest thing from it, but as reference, here's something that we can consider for these bridges. They got to support 4 times the maximum intended load. Okay, I'm not an engineer. I'm not designing these bridges, but that first one we looked at with the plywood, that one did not appear to be sufficient to hold the weight. The minimum width, you got to be at least 20 inches wide. The bridge must extend at least 24 inches on either side of the trench. I'm not sure either one of those met that requirement. Guardrails, because we're, a typical anchor trench is maybe 2 feet deep. Guardrails not required unless it's 6 feet deep. You should always have your temporary bridges inspected by a competent person. And then another thing that's not listed here that I would say would be important to consider would be the surface of the bridge. We want to make sure that, it's not slippy. Okay, so our anchor trench is excavated. Now we're deploying. We're deploying our geomembrane. We ought to be concerned about the wind. So as we deploy longer and longer panels, sometimes they're 500 foot long. or greater, you got that much geomembrane pulled out and a wind picks up, somebody could wind up seriously becoming injured, especially if that material were to come loose in a textured geomembrane. That becomes, you find yourself quickly in a dangerous situation. We recommend that on job sites you have an anemometer, which is a wind gauge. It tells you the wind speed. And you can see here in this other photo here the wind damage that the geosynthetics sustained. So, when these panels do get caught by the wind, they can be a pretty serious situation. You might be walking on the liner and maybe the wind's starting to pick up a little bit and you see the corner of maybe a panel starting to flap in the wind a little bit and you think, I could just stand on it and hold it down. I would recommend you don't do that. Once the wind really gets a hold of that, it's going to pick you right up and take you for a ride. So if the wind does pick up, just step off the geosynthetics, stand upwind, and let the folks that are trained and know how to handle that material take care of the situation. So we got our panel deployed, and now we are starting to cut the geomembrane. The cutting of the geomembrane is going to be occurring throughout, but I figured this would be a good place we can talk about it. You want to make sure you're using safe cutting practices. You make sure you're wearing proper PPE and using the right equipment. Making sure folks are trained and never walk up behind somebody who's cutting with the geomembrane. The knives have a tendency to slip, and if your arm swings behind you, somebody behind you could be cut. So we want to be careful of, even if you're not cutting the geomembrane, you want to use caution if you're working around somebody who is. So if you are cutting the geomembrane, you want to make sure you're using a safety knife with an auto retracting blade. But even that, you still have to be careful because it's only going to auto retract if your thumb lets go of that trigger. So it's a safety tool, but it has to be operated properly. We also recommend you're using the hook blades. If you don't have a hook blade, your blade's going to slip and slide on the geomembrane, and it's going to be difficult to get a good grip on the liner there, and it's more tendency for your knife to swing. You should have cut-resistant gloves. And finally, one thing that we recommend, both for quality and for safety, is that you have some sort of sharps disposal on the geosynthetics. We use that, make sure it's being employed for any type of disposed of blades, but also when we're stitching geotextile, you got needles that might break. You should have a place safe that you can put them so we don't wind up either injuring ourselves or damaging the geosynthetics. Okay, as we're deploying our geomembrane, I already mentioned the anchor trench, but now we've got another potential hazard. You got the geomembrane panel that bridges the open trench. So if you can imagine yourself standing maybe at the top of that slope, you're looking down at all your geomembrane that you've deployed and how nice it looks. You take a step back and you're stepping on that bridge geomembrane. You find yourself sinking down into that trench. It's only maybe 2 feet deep, but if you're standing there and you're falling backwards, that might not be a good thing. So it's just something to be aware of. Okay, so the spreader bar. If we're deploying geosynthetics, we have to deal with the spreader bar. We talked already about the heavy equipment, but the spreader bar presents another potential hazard. In fact, some years ago, there was a fatality in our industry because of the spreader bar. What had happened was the equipment lost control a bit, and the rigged geomembrane, as you can see, we have the spreader bar, that's the bar at the top, and then on the bottom we have the geomembrane with the missiles sticking into it. So what happened is, the roll of geomembrane started swinging, and the metal sticking out of the roll, the missile, wound up hitting the gentleman in the head, and unfortunately he did not make it home to his home that night. So you have to be very careful when you're working around the suspended rolls. We often require that the tags, the inventory tags, are collected from the rolls, but we let the installer get that for us because they're the ones that work around the equipment and the rigged rolls. They get that for us and give it to us in a safe way. Also, another thing to consider if you are the personnel that's handling the rigging and the spreader bar, those are quite heavy. You should be using a back support brace when you're lifting, lift with your legs, and there really should be you should have some help lifting this. The hand clamps. So as they're pulling out the geomembrane, oftentimes they're using these hand clamps. We recommend for quality issues, so we don't damage the geomembrane, that they round over the corners. In the process of rounding over the corners, we might have little small burrs of metal, so you should be wearing gloves if you're using the hand clamps. And then the other thing to be concerned of is those straps. A lot of installers will have the straps attached to the hand clamp, as you see in this photo, and they'll pull the strap instead of pulling the hand clamp. What could happen there is if that hand clamp were to come loose, now you have a flying projectile that could hit you you or your coworker in the face. So we don't want to be careful about that. The other thing for deployment is what we call the triangle of death. As you can see in this image here, this is a situation where we're using either a block and tackle or a pulley. The material is attached to the stationary equipment at the toe of the slope, and it's being pulled up slope. The cable goes up to that fixed piece of equipment at the top and then turns a 90-degree angle. And then as that piece of equipment moves to the left of your screen, it pulls up the geomembrane. Now that creates an area that we call the triangle of death. And some years ago, we had a gentleman that was in our training, our safety class, continued on into a job site later on, and they were using this type of deployment, and he remembered the class. So he had to use the porta-john. He had a choice between two porta-johns, one that was in the triangle of death and the one that was a little bit out of his way. But he went to the one that was safer, even though it was a little bit more of a walk. While he was in the porta-john, the rigging failed. And part of that rigging shot not only into the porta-john that was within the exclusion zone, but it actually went out the other side. So had this gentleman used that porta-john, he probably would not be with us any longer. So just remember what we call the triangle of death and making sure you're outside of that exclusion zone. Your rigging should always be inspected by a competent person. Who should have the ability to stop work. And another option for mitigation maybe is you're using dampers on that cable to prevent them from snapping back. When we're talking about deployment on slopes, anytime you're working on a slope, you have to be careful of upslope hazards. So we have a forklift it's rigged up with a roll of geomembrane hanging down, but also on the forks at the top, it's got another roll of material. So it's very potentially that roll could come loose and then roll down the slope. Here we have a piece of equipment that actually took a tumble, lost control, and came down the slope, and it happened right at where we were working. Luckily, nobody was injured, nobody was hurt in this incident, but you can see it's right where the geomembrane ends. So we had people in this area working, but because we are all concerned about upslope activities, and we were a little bit further back, and nobody was really injured in this case. I think the operator of the equipment was even okay. But as you're working on slopes, if you're using generators or any type of ATVs for deployment purposes, you make sure your wheels are always chocked. Okay, temporary ballast. As we got our panels pulled out onto the subgrade, now we want to make sure they're ballasted in place. Sandbags is something that we often use. So we want to make sure that we're using the proper lifting techniques and maybe using a back brace. And again, the sandbags might be there for days to weeks at a time. You never know what's hiding underneath them. So make sure you got gloves when you're picking them up. Also, sandbags may not just be used for ballast. Sometimes they're used for other things like, controlling water. So they might be considerably heavier than what we're used to picking up. They might be waterlogged or frozen. So just be, if your job involves picking up and moving sandbags, make sure you're doing it safely. As we're starting to walk out onto our geomembrane panels that we just deployed, let's talk about some things so we don't slip and slide. So we want to watch out for extension cords, extrusion welding rod, tools, wrinkles, even the overlap flap from the fusion welds. Those extension cords are going to be running everywhere, and you're going to be stepping over them all day long. But just even if you're stepping over them, just be cautious, because somebody at the other end of that cord could give a little flip to give them some slack, and in doing so, you could be tripping over that cord then. Here's something that you might not consider. Maybe you got textured liner on your project, so you think, well, it's textured, I'm not going to slip. But many textured geomembranes has the smooth welding edge. Now, you could be walking along that textured liner, perfect grip, good friction, and then you hit that smooth welding edge. Maybe that is even wet. We got a little bit of water from some overspray from a water truck that just went, through, nearby. Maybe some condensation or even dust. A lot of people don't even realize that dust can make it slippy. So if you were to step on that without paying attention, you could quickly go down. Different parts of the country, different weather conditions, ice is, even if it's a thin little, just ice or even some frost on the liner could make it slippy. GeoNet is listed here, but we're going to talk about GeoNet here in a little bit. But if you got GeoNet on your project, that's a really slippery thing to consider. Sandbags, again, now they're tripping hazards. So some of these sites we use quite a lot of sandbags. You can see here we used them from ballast on this rain cover. But when we're doing that, we also sometimes have these rope lines in place. So again, that's now something else you got to be careful. Make sure you're stepping over and not tripping on. As you're out there walking on the liner, many sites have some steep slopes. So we want to make sure we're accessing those areas safely. What you're seeing here is probably not the safest way to do that task. But just, as you're walking along and you got some slopes, make sure you're traversing those areas in a safe manner. Here's an image of, this is a fusion weld, and you can see we've got a bit of a wrinkle kind of going on there. As you're walking through that area, your foot might have a tendency to catch that, and that could be a trip. Access and egress. How are we going to get into and out of our work area? All right, well, we already talked about that bridge. But we might have other ways that we need to get into our site. So we've crossed our anchor trench, but what if we have smooth liner? How are we going to safely get up and down to the bottom? Some cells or ponds might be designed even with their smooth liner. Maybe there's every so often there might be the design of a textured geomembrane panel going down in there. What you can see in this photo here, we have a textured panel. This is just a temporary panel. It's going down that slope so folks can come in and out easily. Also, maybe having flaggers at the top of berms. So I got a slide here in a minute I'm going to show you. Here's access. This is a rope ladder. So maybe the folks that you've seen a few moments ago using the vacuum box, maybe this would have been a better option, maybe a little safer. So here's the access ramp, and maybe a flagger might have been a good idea here. This is, although we're not doing geosynthetics yet, we were building the berm, and that pickup truck is the fellow that was doing the density testing. So had he been outside of that truck, maybe near the top of that berm, that ramp there, doing a, squatting down, prepared to take a test, maybe that compactor was coming up slope, and because of the angle, didn't see him. So as they're coming up the slope, they might not be able to see something that's at the top. So maybe we need a flagger. Likewise, this is a real life story, unfortunately. This happened at a landfill in Florida, where a worker at the end of his shift went and used the porta-john. So he thought he was safe. He thought he was done for the day and getting ready to go home to his front door. Unfortunately, there was a bulldozer that was coming up the slope, and because of the angle and because of the blind spot caused by the blade, the operator didn't know that couldn't see the porta-john, and unfortunately ran that porta-john over with the personnel inside of it. It was a very bad situation. Okay, so let's talk about some equipment safety, and this is specifically for the equipment that you might be using on the geomembrane. So we're going to limit it to that. So we'll talk about this ATV here. You can see that we've got the wheels chalked, And you can also see that we've got some cones on either side. So the use of those cones kind of forces the operator, before he drives away, to do a 360 to collect the cones. And then you also note that there is a whip flag attached to it. So as that particular piece of equipment maybe is operating on some haul roads, some bigger equipment can easily see it. All right, so we've got our panels in place now, and now we're going to get ready for some welding. So before we do that, we have to do some trial welds. So the way we do that is we cut out 1-inch coupons. They're samples. We call them coupons or bones. And we're going to test them for peel and shear using what we call the tensiometer. All right, so this is an image of the tensiometer. And the way we get those little 1-inch coupons is by using this die cutter, which we refer to as either the coupon cutter or a bone cutter. You got to remember that that blade that cuts those coupons is surgically sharp. It's really, really sharp. You should never stick your hand or your fingers up inside there to dislodge a stuck sample. You get a sample stuck, you use a screwdriver or maybe another piece of liner to shove up in there to get the sample loose, but never use your hand or your finger. You should always be wearing cut-resistant gloves. And one of my pet peeves about these die cutters is this. I could probably walk onto several job sites today throughout the country, and I could find these bone cutters with the safety guard removed. Any tool that has got a safety guard on it, you should never remove it. And unfortunately, many of the safety managers on a lot of these sites aren't even aware that this is even an issue, because they might not have ever seen the bone cutter being used without the guard, or with the guard in place, rather. So they might not even realize that it's supposed to have the guard. But that's a fairly common issue that I see on several sites all across the United States. Also, with the tensiometers, they're heavy. If you're going to be moving them, you should have 2 people. And then as you're operating them, there are some pinch points, so you should be careful of that as well. The other thing with the trial welds is if you're performing or testing indoors and maybe like an on-site laboratory, just remember that space may also be used for other disciplines. Maybe maybe that's a storage area for the nuclear gauge for the soil testing. Or maybe you got some hot ovens in there, which maybe were used for soil drying, or maybe even if you're using PVC geomembrane, those seams need to be cured in an oven. So you'll be careful about other things that might be occurring in your lab space. All right, so now finally we're starting to weld our geomembrane panels together on our project. So most often you're going to see thermal welding. That would be, it can be broken down into 2 different types. One would be the extrusion fillet welds or the hot wedge fusion welding. We're not going to go into the details, the differences between the 2 in this particular class, this webinar, but it is a thermal weld. It does use electricity and it uses heat to form your bond. So with the heat and electricity, we of course need to use caution. There are electrical hazards, the use of the generator, you have extension cords. You should always make sure you got a fire extinguisher nearby. You should be performing a cord inspection for your extension cords. If you can kind of imagine the texturing on the geomembrane panel, sometimes it's quite aggressive. And as these cords get swung around and dragged across that liner day after day after day, that texturing has a tendency, it could start wearing away the insulation on your cords. So that could be an issue too. So make sure you're doing a cord inspection. You should inspect your cords daily. Some sites have a weekly or a monthly inspection program, but really before you use your cord each day, you should be inspecting it. We all know that electricity and water don't go well together, but I can't tell you how frequently we see extension cords just laying in the water on these job sites. So you should be careful about that, and then also making sure that your generators have the GFCI outlet on them. I mentioned thermal welding can get hot. So what we're looking at here, this is we removed this patch. It's a patch from a 60 mil HDPE liner. So that liner's 60 mil, and that weld was so hot it burned a hole right through it. So the welds are hot, so you have to be careful. Sometimes we're using forced hot air for some of these seams. So again, use caution. For the extrusion welding, we're going to need to abrade or grind the edge of the patch, as you see in this picture here. You should have some sort of face shield on, something to protect your face and your eyes. And the equipment has a guard. So again, this is another piece. This is another tool that's got a guard, and you don't want to remove it. Thermal welding, the equipment you're going to use is heavy. I don't know who all in this webinar has ever picked up the equipment, but it is quite heavy. You should use a two-man crew when you're carrying it up and down slopes. Make sure you're stretching ahead of time, careful bending over. Here's an example of a crew that's doing their stretches before the shift. And then they're gonna purge out the heat degraded material before they do their weld. So that is it's a hot molten plastic. So you should make sure you're wearing gloves, and that should be disposed of properly. Every once in a while, you might see that just drop down onto the liner. We need to repair that, but that then becomes a tripping hazard. So we want to be very careful about those. I'm not sure if anybody here would be dealing with repairing the equipment, but we won't go into a whole lot of detail on that. But just if you are, just make sure you should have only qualified and trained personnel should be doing it. In fact, this is a page out of Demtech's operator manual for the Pro Wedge. There are several things to be considering: the electrical hazards, thermal, heat, fumes, gas inhalation, mechanical hazards, and such. So always make sure you review the owner's manual before you start messing around with any of the equipment. I mentioned the fumes. So some projects are indoors. You can see in the picture on the right that we line the inside of a building here. So you still need the generators, but now you have to use caution because make sure you have enough ventilation. The picture on the left is outdoors, but we had to use a tent in order to create shade to stay within our temperature range. So again, there we have to be careful of the fumes. Speaking of fumes, if we're doing chemical welding, the chemicals pose another hazard. If you are using a chemical, you should be properly trained, have your hazmat training, make sure you have a first aid kit nearby. One of the things with a first aid kit is you should have an eye wash in that kit. Now, many sites will have an on-site eye wash, but the problem we have with that is the eye wash is a considerable distance usually from where the geosynthetics are being deployed. So I like to make sure we have an eye wash quick and handy to the personnel that's doing this work. But the problem is the first aid kits that come with the eye wash come with one. So I always say if you got two, you got one, and if you got one, you got none. So always make sure you got spare eye wash kits, because once it's used, it's done. And then if you don't replace it, the next guy's going to be in trouble. So review your SDS information for your chemicals, making sure that all the bottles containing your liquids, chemicals are properly labeled. You can see here that bottle's not labeled. What they did is they moved their chemical from the main container into a container that's more easily to use in the field, but they failed to properly label it. So that particular chemical is an HH66. It's used for the chemical welding. Here's the SDS sheet. Now we're not going to get into a whole lot of details here, but you can see that there are some concerns specific to that material. And so we want to make sure that as we're moving it into different containers, we're properly labeling it, and everybody that know what that chemical is. All right, so on our project, we've got our seams done, and now we're going to start non-destructively testing them. So our non-destructive test, otherwise known as a continuity test, there's 4 common methods that you're going to see. The 2 most common you'll see are the air pressure test and the vacuum box. Now, I would imagine most folks attending today probably are familiar with both of those, but we'll also briefly talk about the holiday spark test and the air lancing. So the air pressure test, it's a dual track fusion weld. We seal both ends and we pressurize it. In order to pressurize it, we insert this needle. Those needles, the installers can buy them as a kit already put together, but sometimes they, for the lack of a better word, Frankenstein them together. I thought that word kind of goes well with what tomorrow's holiday is in the United States, being Halloween and all. But you know, they Frankenstein these together sometimes with bits and parts from different suppliers. The needle, if they're doing it that way, the needle can be sourced from a mortuary supply source. So, you know, they're intended to go through human skin. So just be really careful if you're working around these needles. Sometimes as a QA/QC, you find yourself reaching into the tool bag that holds these because you want to inspect and make sure that the needles are good, the gauges are good, and just be careful reaching into the storage bags. Also, we use sometimes a flame to soften the plastic a little bit so that we can insert the needle. So you want to be very careful, make sure you have a fire extinguisher around, and you most certainly should not be doing that around any type of flammable gases. The vacuum box test is what we use to test for the extrusion welds. So the way we do that is we apply a soapy water over the weld, and then we use the vacuum box with it creates a vacuum, and then you can look through the viewing window, and just like a hole in your tire, if you put soapy water on your tire, you can find a leak by looking for bubbles. So it's the same concept. The hazard here, of course, is you might have textured liner, maybe with the smooth welding edge again, like we talked about. But now you get your smooth liner and you might be on a slope, and now you've introduced soapy water, makes it even more slick. So just be careful. Also complacency. The QA/QC guy that's watching the vacuum box testing, sometimes that gets really boring. And you know, you just want to make sure your mind doesn't wander. But also you'll notice that, you know, it's a task that has you looking down, and you're looking down almost all the time. So again, make sure you're looking up, looking down, and look all around. With the vacuum box, you're bending over almost the entire day. So make sure you're doing stretching, using care when you're bending over, wearing your maybe even knee pads. The holiday spark test. This is a test that I find that a lot of folks are not familiar with. So this would be used on an extrusion weld where the vacuum box doesn't work, like maybe on a pipe boot. So what we do with this is we have a conductive median we place into the joint of the geomembrane before we extrusion weld it. Then we can apply electricity, and it will create an arc through the hole if there is one, and that will let us know if there's a leak. So we're using electricity that's unguarded, it's unshielded electricity, so we want to be very careful with that. Make sure we have non-conductive gloves. We're using proper signage and cones in our work area. And for Pete's sake, don't use this around any flammable gases. The air lance is used on materials other than the HD and LL, something that's more flexible. And so this applies a forced air, usually 50 PSI, directed at the seam. And again, it's compressed air, high pressure. Again, it's usually 50 PSI. So make sure you're wearing eye protection and hearing protection. So all of our testing is done now on our liner. Now we're ready to do some repairs. So the repairs, you know, it's welded, so I didn't feel the need to go back and talk about all the welding again. But just remember, as we're trimming the patches and doing all this detail work, we run into we have a lot of scraps laying around, and we want to make sure that the wind doesn't pick up those scraps and hit somebody. Make sure you got good housekeeping. If you got scrap piles, making sure that they're ballasted in place. Wear eye protection. Be aware of any sudden gusts of wind, and always be aware of your surroundings. So now our liner's almost done. We got one more thing we got to do is our final walkthrough. So final walkthrough, sometimes we got to clean that liner up. There might be a lot of dust, so we got to make sure it's clean before we can inspect it. So you got you got guys out there with blowers, so make sure you're wearing eye protection, maybe a dust mask. And again, now we got wet liner again. Maybe it's dirty, muddy, we got to clean it up some. So we got the, now we got a wet geomembrane, again, causing more slick and slippy surfaces. On some sites, maybe we got to do some leak testing before we call it good. So here is, and again, we're using exposed electrical source. and it'll find a hole in the geomembrane. And this is conductive back geomembrane is what we're using in this. But again, it is exposed electricity. You shouldn't be touching the testing brush, or that black grounding pad you see at the lower right. Make sure you got the proper signage in place, personnel properly trained, and make sure you turn off the equipment before you do any maintenance. I seen guys several years ago, machine wasn't working right, and he started playing with it, and he forgot to turn it off. He zapped himself pretty good. GeoNet. So now we're moving on from our liner into some of this other material. So the GeoNet. If you ever use GeoNet, you got a piece laying on top of another piece and it's not secured. Like you see in this photo, this patch is secured. But if those cable ties weren't in place, that patch would be slicker than ice. You don't want to be stepping on that because you'll be down quicker than you can imagine. Also, something most folks don't consider is the edges of the rolls of the GeoNet. That could be a sharp surface there as they're moving it around. Your geotextile, we're using needles, so we want to make sure we're disposing of them properly. With the cable ties on the geocomposite, we want to make sure that we're getting those tied properly. But back to the textile, we're using an open flame, so we want to be careful around any gases and make sure we have a fire extinguisher. Sometimes these rolls are free rolled down the slope, and you want to be very careful. That's just a practice that installers will commonly do. With the geocomposite cable ties, what could go wrong with the cable ties? Well, we've been on a project and we've seen, because of the heat, that the cable ties expanded and the buckle came loose. And we've seen some mass failures because of that. So luckily nobody was on the slope when everything came down, but it could have been much worse. So making sure the proper design considerations are being used. And make sure that we're doing everything, quality work during the construction. The drainage with the pipes, we've seen a couple times where fire was started by the dielectric coupler. And at least one of those happened after the contractor left to go to lunch. So you should have a fire watch in place, and that fire watch should actually stay in place well after the welding's complete. Again, fire extinguisher should be in use. Again, we're using heavy equipment for the cover materials, and you can see in this image here, sorry, I'm going back a slide. Again, this was inside of a building, so it's a very, very tight work area. Before you work around heavy equipment, maybe you pull up the blind spot diagram that can be found online. So this is for a D6 dozer. You can see, this shows you all the blind spots on that dozer. Of course, if you have other attachments on that dozer, that could change and make the blind spots even worse. But yeah, that's something that you can look at so you get an idea of what the operator can and cannot see. Here's a rollover that equipment was on a slope and it rolled over. So luckily, none of the CQA personnel was down there checking the synthetics. They were out of the way. GCL. Of course, you got overhead spreader bar. You can see that spreader bar is set up for a roll of geomembrane, which is wider, but they're going to switch back and forth throughout the day, whatever material is going to be on there. So you can see that if you were a guy with a measuring wheel walking on that GCL, that might be an issue as the guy with the forklift is backing up. Tie-ins is a hazard. You got upslope hazards, exposure to waste and landfill gas. Maybe you want to have some puncture-resistant insoles for your work boots. Here's an issue on a tie-in. It's an upslope hazard. And then on this one, this came rolling down the slope. It is an area where people were working, but luckily everybody had gone to lunch. So when we came back from lunch, we found this big concrete cylinder that had rolled from the slope up above. So you want to be really careful about working along a tie-in in any activities that are happening upslope from you. All right, so as we wind everything down, I have a homework assignment for you, okay? So I want you to go back to your jobs, your projects, and look at your health and safety plan. I want you to do a Google search, or not a Google search, but a document search, and find out, just search some keywords here. Search for geosynthetics, search for geomembrane, GCL, geocomposite. These are all the common materials that we use on a geosynthetics installation. Do a keyword search. Let me know if you find anything in your safety plan regarding those, okay? So let's wrap it up with another front door. I don't know what your front door looks like. I took a guess with this one. But really the idea is who's waiting for you behind your front door, okay? I will hopefully that you guys learned something today, and maybe that will help you to get back to the folks that are waiting for you at the end of your shift. So with that, we're wrapping it up today. The next webinar. Yeah, the reminder that we do have a Q&A coming up. The next webinar is Mastering Extrusion Weld Examination, Essential Checks Before, During, and After Welding. So that will be held Thursday, November 20th at 12:30 p.m. Eastern Time. And now we have questions and answers. So if you bear with me for just a moment, let me check and see what we have here. Where are they at? Okay, so we do have one question here. Any tips for daily tailgate meetings and ensuring everyone understands? So that's a good question. Thanks for asking that. So daily tailgate meetings should be held every day, we believe. And so often we see that usually it's just the contractor that's holding them. And a common sight we see is that the QA may not attend. So we believe that everybody that's going to be involved in those tasks on that particular day attend the meeting. So the other thing is making sure everybody understands. That's actually a pretty good concern, because on some of these crews you have different languages that are spoken, and there may be a language barrier. So we want to make sure that we have an interpreter if it's needed on your site for your crews. Another thing that we can consider is that different folks might be scheduled at different times to arrive on your job site. So maybe somebody that is arriving later in the morning maybe has missed your daily tailgate meeting. But so before that person works in your area, you want to make sure that they're caught up with anything that was discussed at the tailgate meeting for safety concerns. All right, so I think that was the last question that we had for today. So again, we thank you and we hope to see you next month. Thanks for joining us and have a great day.